Hey gang, I want to talk to you about getting your head in the clouds and using cloud-based wireless LAN controllers. And of course, since we're talking about Cisco here, who did Cisco buy out to make that happen? Meraki. And again, I've been known to pronounce this Meraki, but technically it should be the Meraki. It's actually a Greek word that refers to a zest or passion, like, oh man, those old world craftsmen really had a lot of Meraki for their work. So here's our configuration where we're using this, right? We've got our various different devices that are going to have, of course, their access points that they are connected to, which are, of course, associated with switches to get onto the wired network. But out in the cloud, we maintain essentially a cloud-based controller, not a device that we would ever manage. That's the whole point of it being cloud-based. But the controlling service is out there in the cloud. And so, as we deal with providing this kind of configuration, all of the configuration instructions are going through a web-based protocol, web-based access, in order to instruct the access points in terms of how they should behave. This allows it to go through various firewalls. It's not going to have to use the same direct CAPWAP protocols, for example, that we would use in our LAN. In this configuration, it works much more like a remote edge access point or hybrid remote edge access point, or as we now call it, a Flex Connect. Again, remember REAP, HREAP, and Flex Connect are all essentially evolutions of the same technology. In all of these configurations, what happens? Not only in these situations do we have the access point handling frame management and probe and beaconing and CSMA CA, but additionally, in all of these scenarios and in our Meraki scenario, the client is going to emerge onto the network right here, right out this access point and the connection between that access point and the switch. So that's how it's going to appear. It is not going to be coming out of the cloud, coming out of the LAN controlling service in the cloud. That wouldn't make sense. It's coming from inside your network, directly from your access points, like it would in, let's say, an autonomous configuration. So let's take a look at our different flavors of Meraki devices. Again, as we're going to see, we can, for any one of these, essentially scale up, right? So we can pick and choose essentially where we want to be on the axis of cost and in terms of power, potential, bandwidth, availability, those kinds of things. Moving from the 18 to the 26 to the 32 to the 34. One thing we're going to see is that there's several different radios, and one of them is going to be associated with intrusion detection and intrusion prevention of the wireless nature, as well as RF optimization and spectrum analysis. In other words, you don't have to get a dedicated Meraki device just to perform those things. It's already got a built-in radio to handle those kinds of issues. So at the bottom of the heap here, we're looking at the 18. At the 2.4 gigahertz, we've got BG and N, of course. At the 5 gigahertz, we've got A and N, but notice no AC at this level. We've got the dedicated intrusion detection and prevention radio. And so with a 2x2 MIMO and 2 spatial streams and beamforming, we can get 300 megabits per second in terms of data rate. When we bump that up to the 26 is essentially the same, except it's 3x3 with 3 spatial streams, and so that gets us up to 450 megabits per second. Notice at the 5 gigahertz, though, we still don't have AC, right? So again, we're getting more power in terms of additional antenna, more spatial streams. We can manage our MIMO better. We can use beamforming with our clients, but we're still doing that at an N level, at a maximum. When you jump up to the 32, now we get to 802.11ac. All right, great. Now we've got the AC support. And notice it has the BGN, the ANAC, the dedicated radio for intrusion prevention and detection. It also has a Bluetooth radio, and that's associated with being able to, again, manage Bluetooth connections that can go across this. And this is a 2x2 with 2 spatial streams and beamforming, which means it can, at the AC level, handle up to 650 megabits per second in terms of its data rate. Now, when we go to the 34, once again, we see the BGN and the AC and the intrusion prevention. And this is a 3x3 with 3 spatial streams and 975 megabits per second max data rate. So again, and notice this guy even looks a little different, a little bit upgraded technology here in terms of they kind of rebuilt the platform and the antenna placement and all of that. So had a lot of luck with this one myself. And again, this is kind of the for interior uh, access points that are cloud based from Cisco. This is kind of the top of the heap of what you got. Good stuff, high data rate, and again, the about as good as you can get for Wave 1 technology.